Hello everyone, my name is Andrea Velasquez and my teammate Maria Saavedra. We're going to present our project and we hope you enjoy.
So today we will be doing the key assignments. We were assigned this problem that says the graph of the function f is shown above consists of a semicircle and 3 line segments. This is the graph and this is the semicircle and the 3 line segments. Let g be the function given by g of x from integral from -3 to x f of t dt. The first question we have to solve is find g of 0 and the first derivative of g of 0. The first thing that we have to do is substitute this value of x in our original function that was given by us in the beginning of the question. So we will put g of 0 equals, and we will substitute this 0 here. So it will be an integral from -3 to 0 of f of t dt. So here we will have to find what f of t is, and since our integral tells us that it goes from -3 to 0, here in the graph we can observe that from 0 to -3, we can see that this is a line segment that we are going to be using. This will be our f of t. So in order to get the equation of this function, we will take these 2 points. Here is -3 and 2, and here it will be 0 and 1. In order to find our slope, we will put these 2 points in our equation, our slope equation, which is y2 minus y1 and x2 minus x1. This will be our x1, y1, this will be our x2, y2, and we will substitute these values. So it will be 1 minus 2 and 0 plus 3. This will be equal to -1 over 3. This will be our slope. Then to find the b, if we were to put it in our equation, this would be our slope and we would have to find b. In order to find b, this is our original equation, this is our slope, and we will find b. In order to find b, since we have to find our b and we can see that the intersection of this line segment in the graph is 1, then we know automatically that our b will be 1. So now that we have our equation, we know that this is f of x, f of t, then we can substitute this here. We will put g0 integral from -3 to 0, and this function will go here, -1/3 of x plus 1, all of this dx. Then we will integrate this value, and we will see that g of 0 will be 1/3, and remember that when we integrate, we will have to elevate, we will add 1 to the exponent and put that value at the bottom, and then this will become x. We will evaluate from -3 to 0. Then we will substitute these values. This will multiply and this will become x squared over 6 plus x. Then we will substitute these values beginning with the biggest number and then with the smaller number. So -0 squared over 6 plus 0. All of this will be 0. And then this will be -3 squared over 6 plus -3. This equals, since this becomes 9, positive 9, and a negative number, it will be -9/6, and with this negative, it will become a positive, and this will become -3. If we were to solve this, then we will find that this equals 9/2, and this would be our final answer. In order to write out our solution, we will say that g of 0 equals 9/2, and that will be our final result. In order to find the first derivative of g evaluated in 0, it is necessary to take in account the second theorem of calculus that states that we will have to derivate this x that will become g derivative of 0 equals 1 times f of x. Since the first derivative of x is 1, and then we will insert this x here where t is. We will substitute the value and it will become f of x. Then we will evaluate this in 0, and we can see that in our graph, f of x in 0 is 1, so our result will be 1. This is our solution.
Okay, so this part is more than, it says final values of x in the open interval, -5 and 4, at which g attains a relative maximum, and justify your answer. Okay, so as we know, this is the graph of f, and it's represented by also the derivative of the graph of g. It's really simple to know because we know that when the value of of the derivative is changing from positive to negative in the graph, it means it is a maximum. So we can just write that here in 3. It's a maximum, so we write, since the graph f is the derivative of g of x, then we can find a relative maximum at the point x equal 3, because the line segment crosses the x-axis from a positive to a negative value. And that's it. Question C says, find the absolute minimum value of g in the closed interval -5 and 4. Then justify your answer. So we have to see that we are asked about the absolute minimum, not just the relative one. So we need to do a sum of areas here because we're talking about integrals. So it will be easier to just get the areas of the figures that we have in this graph and then check which one is the smallest one. So we have these two triangles that have the same area, just one's negative and the other one's positive. Then we have this trapeze. Then we have this rectangle without a semicircle, the area of the semicircle here. And then we have these two little triangles that are actually the same, but negative and positive areas. So we have to see that we have the area of a triangle. The formula is base times height over 2. We also have the area of a trapeze. Its area is the side 1 plus the side 2 over 2 times the height. And also we have the area of a semicircle or a circle. It's p times radius squared over 2 if you're talking about a semicircle. And okay, so we have the first two triangles. Its height will be 2 and its base will be 1. So we put 2 times 1 over 2, that will be 1, and also minus 1. Then we're getting the area of this trapeze. The area will be side 1, it's 2, plus side 2, that is 1, over 2, times the height, that in this case is 3. So we solve it, it will be 3 plus 3/3, that it's equal to, sorry, it's times, and then we have 9 over 2. And then the area of the rectangle and semicircle. The rectangle, as we can see, is 2 times 1, so it's just 2. And then we have to solve the semicircle. The radius of the semicircle is equals 1 because it's the half of the diameter. So the area of the semicircle will be p times 1 squared, that's 1 over 2. So we have pi over 2. And so the total area is going to be 2 minus pi over 2. This is similar to 0.43. And then the last area we're going to find is of the other triangles. It's equal to, as you can see, 1 and 1. So 1 times 1 over 2, that's equal to 1/2, and minus 1/2. So now we compare the areas, and we can see that this smallest area will be -1, and as there cannot be the minus because we're talking about areas, so we just put the 1 entirely. So the minimum of the function g is 1. So we have to specify, that it is the absolute minimum. And then we justify it because it is the smallest area found. Is the minimum because in this part the area is negative a little bit, and then all the graph is just increasing and increasing, and even though it decreases here, it doesn't compare to the amount of increase that we already had in our graph. So we can see that is the part that it decreases the most.
Okay, for the last question, it says find all the values of x in the open interval -5 and 4 at which the graph of g has a point of inflection. So remember, to find the point of inflection, we have to follow the rule that says f of x has inflection points whenever there is a maximum or a minimum in the graph of its derivative. So that would be in f of x, first derivative of f of x. So here in the graph, we can see that we have maximum and minimum points here, 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 and here, because so we see in the graph that whenever the function increases and starts to decrease, we will find a maximum, and whenever the function is decreasing and begins to increase, we will find a minimum. So here it is increasing and it begins to decrease, so this will be an inflection point. It decreases, it keeps decreasing, this will be another inflection point because then it starts to increase, and here it starts to decrease again, so this will be another inflection point. Here it is not an inflection point because there is no change of sign in the graph, because here to all the way here the graph is decreasing. So here the answer would be the inflection, the values of x in the open interval of -5 and 4. There is inflection points at x equals -3, because here there is one inflection point and in x it is -3. Then this was another inflection point, so it will be 1, and here there is another inflection point, so that will be 2, and that's it, because -5 and 4, they are not included, so we will not take them into account. So this is our final answer.